In the early dark universe, as stars and galaxies were just beginning to form, monstrous entities emerged. These were the first black holes, born from the remnants of massive stars or the collapse of dense matter. Devourers of all in their path, even light itself, they cast a shroud of darkness upon the cosmos, forever altering our understanding of the universe's immense power and mysteries. This is a theory that we came up with to explain how these awe-inspiring monsters may have come into existence. But is this really how these monsters formed in the early universe? The origin of the first black holes continues to be a subject of intense debate among scientists. How did they grow so massive and powerful in such a short time? And what can they tell us about the origin and evolution of the first stars, galaxies, and quasars in the universe? In the early days of the universe, just 570 million years after the Big Bang, and according to a new study in Nature Astronomy, a team of astronomers using the powerful James Webb Space Telescope reported the discovery of an accreting supermassive black hole lurking in the darkness at Z=8.679, which is about 13.3 billion light-years away from us. This means we are seeing this black hole as it was only 570 million years after the Big Bang, when the universe was very young and dark. This black hole is so massive and powerful that it can outshine its host galaxy, which is also one of the earliest galaxies ever observed. This discovery, made by astronomers using data from the James Webb Space Telescope, challenges our understanding of how supermassive black holes form. Previously, it was thought that supermassive black holes took billions of years to grow. But the discovery of this black hole, which is about 100 million times the mass of our Sun, suggests that they may be able to grow much faster than previously thought. This discovery is exciting, surprising, mysterious, and important for several reasons. First, it is one of the most distant and luminous black holes ever detected. Second, it challenges some of the models of how black holes form and grow in the early universe. Third, it provides a unique window into the conditions and processes that shaped the first stars, galaxies, and quasars in the universe. This discovery is sure to lead to further research and new discoveries in the years to come. It also raises many questions and puzzles for astronomers. How did this black hole form so quickly after the Big Bang? How did it acquire so much mass and energy? How did it affect its environment and influence galaxy formation? And what can we learn from its emission lines and spectra? In this video, I will try to answer these questions and more by explaining how this discovery was made, what it means for our understanding of the early universe, and what the implications and future prospects of this discovery are. So buckle up and prepare to have your mind cosmically blown as we rewrite the cosmic history. Black holes are regions of space where gravity is so strong that nothing can escape, not even light. They are formed when massive stars die and collapse under their own weight, or when dense matter clumps together under extreme conditions. These black holes can grow by accreting matter from their surroundings, or by merging with other black holes. But how did some of them become so massive and powerful in such a short time? The origin of supermassive black holes, which are millions or billions of times the mass of the Sun, is one of the biggest puzzles in astrophysics. These black holes are found at the centers of most galaxies, including our own, and they can influence the formation and evolution of stars and gas around them. They also produce enormous amounts of radiation as they devour matter, creating bright beacons in the sky known as quasars. Quasars are among the most luminous objects in the universe, and they can be seen across vast distances. By observing them, we can learn about the properties and environments of supermassive black holes, as well as the conditions of the early universe. However, finding quasars in the very distant past is not easy, because their light has been stretched by the expansion of space into longer wavelengths that are beyond the reach of most telescopes. This is why astronomers were eagerly anticipating the launch of the James Webb Space Telescope, as its exceptional infrared capabilities are perfectly suited for studying distant quasars and galaxies. The telescope has already demonstrated its success by observing numerous ancient and far-reaching galaxies, leaving scientists puzzled and prompting a re-evaluation of our fundamental theories. One of the first targets that James Webb observed was a galaxy named Sears 1019, which was previously known as EGSW 8P7. This galaxy was discovered by Hubble in 2015, and it is one of the earliest and most distant galaxies ever detected. It is located 13.1 billion light-years away from us, which means we see it as it was 570 million years after the Big Bang. This galaxy is very faint and small, but it has a surprising feature. It hosts a supermassive black hole at its center that is 10 million times the mass of the Sun. This black hole is actively feeding on gas and dust, creating a quasar that is 1,000 times more luminous than the Milky Way. This quasar, named J03131806, is the earliest and most distant quasar ever found, and it is also the earliest and most distant supermassive black hole ever found. How did this supermassive black hole form and grow so fast? This is a question that astronomers are still trying to answer. One possibility is that it started from a seed black hole that was formed by the collapse of a massive star or a dense cluster of matter in the early universe. However, this seed black hole would have to be very large and grow very fast to reach 10 million solar masses in such a short time. Another possibility is that it started from a direct collapse of a massive cloud of gas that skipped the star formation stage and went straight to forming a black hole. This scenario would require very special conditions, such as low metallicity and strong radiation from nearby stars. To test these hypotheses and learn more about this supermassive black hole and its host galaxy, astronomers plan to use James Webb and other telescopes to observe them in more detail. They hope to measure the mass, spin, and accretion rate of the black hole, as well as the properties of the gas and stars around it. They also hope to find more examples of early supermassive black holes and quasars in the universe, and compare them with each other and with their counterparts in later epochs. The search for the earliest supermassive black holes and quasars is not only important for understanding their origin and evolution, but also for understanding their impact on the universe. These objects are thought to play a key role in the reionization of the universe, which is the process by which the neutral hydrogen that filled the early universe was ionized by radiation from stars and quasars. This process made the universe transparent to light and enabled us to see further back in time. By studying these objects, we can learn about how they contributed to reionization, how they affected their surroundings, and how they influenced the formation of later generations of stars and galaxies. The discovery of J03131806 is a milestone in our quest to understand the origin and evolution of supermassive black holes and quasars in the universe. It shows that these objects existed much earlier than we thought, and that they pose fascinating challenges for our theories and models. It also shows that James Webb is a powerful tool for exploring the distant and dark corners of the cosmos, where new wonders await us. This supermassive black hole is just one example of the mysteries that await us as we explore the origins of stars, galaxies, planets, and life. How will these findings change our view of ourselves and our place in the cosmos? Stay tuned for more updates. Thank you for watching this video. If you liked it, please give it a thumbs up and subscribe to the channel. And for more content like this, check the playlist. If you have any questions or comments, please leave them below, and I will try to answer them. Until next time, keep looking up and stay curious.